Hello, math nerds. It's the crazy math nerd, Kitty Morgan here. And we're going to take another look at those basic functions because they are really a big deal in our life. We're going to see them a lot. And we're going to look at graphical limits. And so I'm going to do the ones I have circled, and then I'm going to let you do the rest of them. Okay, here we go. Let's go have some fun. All right, so we're going to start with 2a. So it says the limit as x, well, I can't see that right there. Sorry about that. There you go. The limit as x approaches 2 of x squared is. Now, what does that mean? What y value are you approaching? And y'all, at 2, let's just look at the graph at 2 right there. Ooh, there it is. Kinda. There it is. I'm not having a very good time with my pen. Sorry about that. That's a nice, smooth, continuous, wonderful function. We love it. It smiles all the time, right? So coming from the left and the right is definitely going to have the same limit because it's nice and smooth and continuous there. So if we can just go find out what the value is, and I think that's 4. So that's the limit. So if you've got if you're asking a question about a limit as you approach a number, and at that number it's nice and smooth and continuous, whatever the y value is right there is your answer. Isn't that easy? Love this, I know. So let's look at x cubed, and I'm going to read the question because we're kind of getting used to this, right? So the limit as x approaches, remember every time I see that arrow, I say the word approaches, 1/2 of x cubed. You can say a little backwards. You can say the limit of x cubed as x approaches 1/2. You can do either. It doesn't matter. So if I go on the graph, I don't know exactly what that is. So I can see the 4 very clearly in the first example. Can't really see. But, we did say, and this is a nice, smooth, continuous graph. So whatever the y value is should be the limit because there are no breaks or jumps or anything there. So why don't we just plug in 1/2 to x cubed, and won't we get 1/8? And that does look like a very small value there, but if you want to find it, I think we can just find the y value, which means just plug it in and get that value, right? Okay. Man, this is so easy, this calculus stuff. What is going on? Okay. So we're going to do 5a and c and 6a and c. And 5 is a little different because he's a square root, and he has domain issues, but he's continuous for what he has, greater than or equal to 0. So what happens if we go to 5? The limit as x approaches 5 of the square root of x. Well, I'm going to make me a little mark. It's right there, a little over 2, which would make sense because the square root of 4 is 2. So the square root of 5 would be a little over 2. And I don't know what that is, so you know what I'm going to do? I'm just going to write the square root of 5. Because that, I mean, if you evaluate this function, which it's nice and smooth right there, then that should be the answer. So I'm just going to plug in 5, and there it is. Okay. Now C is going to be a little different because we're coming into 0 from, oh goodness, we're coming into 0 from the right. So my pen is really going crazy on me, on my little surface. So let's look at that. What does that mean? Go to 0 on the graph. Okay, there it is, right there. And for some odd reason, when I do that, OneNote wants to show you all that menu. Sorry about that. And you're going to go to the right, and then you're going to go towards that x. And as you go towards that x, what y value are you approaching? And you are approaching 0. There is no other side, so that's why we don't ask about the other side. There is no other side. So I'm going to read part C for you. The limit as x approaches 0 from the right, remember that little plus means from the right of square root of x is equal to 0, because if you go to the right of 0 and you go towards it, the y value it's approaching is 0. This next little guy is a little weird. He is also lovingly known as the step function. That's his nickname, but he's really called the greatest integer function. And I think we talked about him when we talked about going left and right forever. So these are the two things you might hear him called, so I wanted you to know that. So let's go look at what's happening as x approaches 2.3. Well, if you go to 2.3, somewhere right in there, I don't know, then up here on the function itself, it's part of that little line between 2 and 3. So where it is very smooth and continuous and doesn't have anything going on. So the y value there is actually 2 from both sides because it's in the middle of those little steps. However, when I go to part C, I have to look at 2 from the left and the right. So let's do that. So here's 2, like here's 2, and coming in from the left, it's going to 1, and coming in from the right, it's going to 2. Goodness gracious, my pen is so nutty right now. I'm going to blow this up just a little bit. Oh, good, that's helpful. All right, there's 2. Coming in from the left is 1. Coming in from the right is 2. So what happens if we come in from the left and the right and the values don't match? We say, and it's not really equals, but we say the limit does not exist. Right? If the limit from the left and the limit from the right, if they're not the same, we don't have a limit. All right, there you go. Well, that sounds like a song. Okay. Let's look at number 8 now. I love x to the 2/3. He's so cute. He looks like a bird. But notice that he is nice and smooth and continuous, right? I don't see any breaks or jumps or vertical asymptotes or anything. So if I want to know the limit as x approaches 8, then I can actually just plug 8 into the x and get the y value because the y value at 8 will be the limit because it's smooth and continuous. So how do I do that? So I'm going to do 8 to the 2/3. Now, when I do something like this, I think about it like this. I want to break it down first and then raise it to the power because there is a cube root of 8 and that'll make it smaller, and then I'll square that. So the cube root of 8 is 2 and 2 squared is 4. So remember that the denominator of a fractional thing is your root, and the top part of a fractional denominator is your power. And if you can ever break it down by taking the root first and then building that smaller answer back up with the power, that's normally what we try to do. Okay? And then on number 9, it says what's happening as you go to 0. Okay, so let's say this correctly. Come on, Miss Morgan. So the limit as x approaches 0, and if there's not a plus or minus, that means from both sides. So where is 0? Here's 0. If you come in from the left, you go down forever. So I'm going to think about this for a minute. It's my thinking cloud. So the limit as x approaches 0 from the left is negative infinity. And the limit as x approaches 0 from the right, I don't know what that is, I haven't done that yet. So let's get on the function to the right of 0 and go meow. It goes up forever. So because they're not going in the same direction, we cannot say a directional answer, okay? We have to say that it does not exist. Remember, it's not really equals does not exist, it just does not exist. And I'm going to erase this now because I did not plan well for my time, did I? Does not exist. Okay. Now, what happens when we look at his friend? 1 over x squared, let's look at 0 there. Now, you know, when you say it goes to 0, it means from both sides. So if you come in from the left, meow, it goes to positive infinity. And you come in from the right, meow, it goes up forever, positive infinity. So because this limit does not exist but goes in the same direction, we're going to put an answer of positive infinity. And what does that mean? Number 1, it means the limit does not exist. That means there is no y value that it is approaching. And 2, it tells you the direction of the graph. So when I write b down, when I write this down, if the limit as you're going to a number is positive infinity, I know that at that point, and I know what the graph looks like, but at that point, both sides are going up on either side of it. That's what that means. Both sides are going up. If you have, I'm going to go back to this one, if you have the limit as x goes to a number and you have a does not exist, that probably means you have a vertical asymptote and both sides are going in different directions. Sometimes it means that. Well, it could mean that there's a jump or something in there, but that's one of the things it could be, okay? All right. So I think that's enough to get you going. I think that's all we're going to do for that one. Yeah. So please finish the rest of that, and I'll talk to you soon. Bye.